Hello, this is my robotics project. So this is a strawberry picking robot that I programmed back in 2023, and I've been working on this project on and off for about 2 years, but I recently just rebooted the project and added a lot more core features to this robot. So it's a 6 degrees of freedom robotic arm, which I've programmed to be able to locate, pick up and manipulate objects in 3D space. In this instance, strawberries. So this could have applications in agricultural technology, for example, with harvesting fruit or packaging fruit. And I'll tell you a little bit more about how this project works. So this is an Intel RealSense depth sensing camera. This is a really critical component of the whole pipeline. What's special about this camera is that it can detect objects in 3D as well as 2D. So if you take an image of a strawberry, it will tell you how far away from the camera that strawberry is. So instead of just getting the regular X, Y pixel values that you'd expect from a camera, this will give you X, Y, and Z. It'll tell you how far away an object is. So just think of this as a camera that takes an image in 3D instead of 2D. So this camera is connected to my desktop, which is running 2 deep learning image processing networks that I've trained. So the first one is an object detection network. It's a specific implementation of the single shot multi-box detector. And its role is to just take a photo and look for any strawberries. If it finds them, get the X, Y, Z values and transform them into coordinates from the robot's frame of reference. So send those coordinates to the robot will perform inverse kinematics on those coordinates and find the exact joint states to set these servos in each of the links of this robotic arm so that it can move and position its end effector to just the right place to pick up a strawberry. The other network that my desktop is running is a custom one that I built myself, and its role is to basically predict the pose of the strawberries and change and estimate the strength of the gripper. So obviously these strawberries are quite delicate, and you've got to pick it up with these 2 little prongs at the end of the arm, and if you grip it too hard, you're going to bruise the strawberry, or if you grip it from the wrong angle, you're just going to completely miss it. So the second network that I've trained on this, its role is to estimate how hard to grip the strawberry and from what angle of approach the gripper should be coming in from. So let's give it a go, see what happens. This section here, this is just a HTTP server. It's awaiting a request from the robot to run the deep learning models. So if it receives a request, it'll take an image, feed that through the network and return the results to the robot. This window here, this is a ROS script. This whole project is written in ROS. So when I press enter, this will just start all the scripts or all the nodes that are required for the pick sequence. Start that now. And in this terminal here, I can just give it a command, pick strawberry, and that'll send a request to the HTTP server, and it will launch the set of actions that the robot has to take in order to pick a strawberry. So let's give that a whiz. All right. I'll press it in 3, 2, 1. Let's see what happens. There we go. So it's clearly found some strawberries. And as you can see, it's rotating the gripper to just the right angle so that it can pick it up from the area with the maximum amount of surface area. And it's placing it in the bin. That's 1 out of 3. It's 2 out of 3. There we go, just managed to grab it. All right, 3 out of 3. And there you have it. That's my strawberry picking robot. Work in progress.